So this is a trig word problem. A spring attached to a platform bounces up and down according to the equation d of t, which equals 3 sine pi by 6t plus 4. D of t is the displacement in centimeters, and t is the time in seconds. So before we graph the function, let's just chat about some of the features of this sine graph. We're going to start with the amplitude. The amplitude is the same as the vertical stretch factor. So this number here, so 3 is the vertical stretch or the amplitude of the function, half of the vertical height, or the distance between the center and the maximum, or the center and the minimum. So determine the period of the function. For that, we are going to take 2 pi and divide it by our c value. And that's always the formula that you want to use to determine the period of the function if it's been changed. So 2 pi divided by, this is my c value here, pi by 6. That gives me 2 pi times 6 over pi. Pi's are gone. 2 times 6 is 12. So 12 seconds is the period of this function. Key points then will happen every 3 seconds, because 12 divided by 4, or every quarter of a 12-second cycle, would be 3 seconds. So that's going to help us set up our scale. The other thing we need just before we start to draw the graph is we need to know the maximum and the minimum. The maximum is the amplitude plus the vertical translation, which is this number here. 3 plus 4 is 7. The minimum is the center, so the vertical translation, minus the amplitude. 4 minus 3 is 1. So the maximum y value is 7, the minimum y value is 1. And now we are ready to draw our graph. So we're going to go over here to our graph. You'll see that I've marked on the maximum value here at 7. So this is the max y value. The center, which corresponds to the vertical translation, is at y equals 4, and the minimum at y equals 1. You'll also notice that the scale I've selected to use every box is worth 1 second. A full period is 12 seconds, so 1 full cycle. And every 3 seconds, you will have a key point. So at 0, we're at 4. At 3, we're at 7. 6, we're back to 4. 9, we're down to the bottom at 1. And 12, we're back to the center again. So back to the center of our graph, which is at 4. So creating a graph is quite simple if you do that planning ahead of time. If you know your scale for your x and y axis, then you're usually in pretty good shape to create your graph. There is no phase shift that we need to worry about. Now, we wanted to know what is the displacement when we have a time of 8 seconds. So on the graph, if we go up to at time equals 8, we get something just a little bit less than 1.5. So that's going to give us kind of an estimate of what our answer should be. D at 8 is going to be 3 sine pi by 6 times 8, and then plus 4. And if I type that into the calculator, I end up, I believe, with 1.40 centimeters. So this point here, this x here is 8, 1.4. Okay, and then the last part of the question was to see if we can create a cos graph to represent this same function. So what I like to do is to sketch cosine in its standard position with all of the same features I looked at. So I'm just going to take the sine and switch it out for cos. So I'm still going to have the same characteristics. I'm just going to draw 3 cos pi by 6t plus 4. So the only change with that, of course, you'll recall cos starts at the top, center, bottom, center, top. So it's the same graph, it's just been shifted over. So it starts at its maximum instead of its center. And I want to take that purple graph, the cos graph, and I want to shift it to make the red graph. So hopefully you can see on there that I'm going to have to shift it 3 units over to the right in order to do that. So all of these points are shifted 3 units over. Oh, I got the wrong one there. I want to go from the purple to the red. So shift this one over 3. That one over 3. This point's going to go over 3. And that point goes over 3. Okay, so when we rewrite our equation then, d of t is going to be 3 cos pi by 6 t minus 3. We'll shift it 3 units to the right and make sure you put it inside brackets in factored form, plus 4. So the only change there is that we're putting in this t minus 3 to shift everything over 3 units to the right.